Hello. Unfortunately, this week we had a live class over Microsoft Teams, but I forgot to hit record. By the way, I did that in the Thursday class as well. So I'm recording this after the fact to go over all the detail that we went over in class on Wednesday with our advanced classes example. So let's take a look at what we did. So we were on the 40S page, and we were looking at here 10, the advanced classes content, okay? And it's sort of a continuation of where we left off right before school closure. So actually what I've done here is I've opened up the PowerPoint presentation of whereabouts we'd been through. So we were kind of at this point here about to study polymorphism. We had looked at the idea of static variables in memory, and we were on to the idea of polymorphism. And we were also at this point in our coding as well. Okay, so what we had done was we had made a method called whatis that uses within that method something called the instance of operator to check to see, is this object, which was the parameter, an instance of one of these class types, okay? So what I wanted to do today was to create 3 more classes to try this out with. A doctor class, a computer science teacher class, and a Mr. Walks class. So we ended up doing that. We ended up going and right-clicking and making a new Java class, one of which was the doctor class, and all we really added to this code was a doctor is a person. We didn't even bother filling out a constructor method. We just left it kind of as is. We then did the CS teacher the same way and just said CS teacher extends teacher. For that, though, we did have to make a constructor where the name was passed along to the teacher object. This was actually pretty easy because once you do this, a light bulb, as you know, can pop up right over here, and it helps write the constructor method for you. Similarly, we did the same thing with the Mr. Walks class. And Mr. Walks extends a computer science teacher. And once again, we'd use the light bulb to help write the constructor that was there. Then we instantiated those 3 objects. So we made a doctor, a comp sci teacher, and a Mr. Walks object. Then we used the whatis method on those 3 brand new objects. So in order for that to work, we had to add a little bit to the whatis method. We added these 3 lines here to see if the object was an instance of one of those 3 other objects. And if it was, we changed the way the output came out by adding something to the name. Okay? And we tested that and we ran it. And again, when we did this live in class, I actually typed the code in, but since this is after the fact, and here you can see the doctor, the teacher, including the CS teacher and the Mr. Walks object, were all outputted by the whatis method. Okay, then what we did was we made a class called the meeting class. Now this is what relates to polymorphism. And this example I do in class is not to reteach the lesson to you. You absolutely should reread these PowerPoint notes or watch the videos that go into this, like a live in class where it talks about polymorphism. I believe it might be something like this video that goes into it, where it. Let me just mute it. Yeah. So this would be the video, Advanced Classes Part 5, where it also talks about polymorphism. And then it also creates like classes like doctor. And then it also creates a meeting class, which is what we were doing. I do in the videos obviously go in more detail. But in our example, we created the meeting class. We added 3 properties to this class. Since the making of the video, I have added the comments to these as well. Okay. A max constant, a count integer, and an array of person objects. We created a constructor method for the meeting that set those variables, set the array, and looped through the array using an enhanced for loop. Okay. And then we made an attend meeting method, how to attend the meeting. And we wrote the code for that, including a little if statement check to make sure we don't exceed the max. And then finally, we made a little hold method that holds the meeting by doing an output and looping through the entire array, again using an enhanced for loop. And as long as the member is not a null, having the member call upon its talk method, which is of course built into the person class. We did that and we tested it. Let me back up a step. We then created a meeting object and added a ton of people to that meeting. All the people objects that we'd been creating, including the new ones, but also the ones before that we had made in before the school closure, and then held the meeting. And our output showed that the meeting went down. There were 6 students at the meeting. Each one used its talk method. Just to back up a step on the meeting object, we also used the total students static variable, which was something we covered just before school closure. So that's where we were. And then we continued on through the concept of polymorphism towards now the concept of abstract classes and methods. Again, this is around slide 45 of this presentation. You should definitely read about this, where it then goes into the example of abstract classes and methods. But we did that by making an abstract class called food, by adding the abstract keyword in there. We created a protected property called nourishment, and a public property called flavor, and a private property called group. So this was, again, to just review the 3 levels of encapsulation: public, private, and the new one in this unit, protected. We then made a public, static, and final property. So it's a constant that's shared and is public. It's an array called groups, and we preset the 5 food groups. We then made a food constructor where you pass it the nourishment, the group, and the flavor. And it assigns it from the parameters over into the properties of the class. We made a digest method and a smell method in this class, just some simple outputs. And then the more interesting ones, we made abstract methods. And abstract methods have no method body. They have no curly brackets. They end in a semicolon. And the purpose of the abstract method is then we made banana objects that extended the food object. What you would have seen is a light bulb would have appeared here saying you had to implement those abstract methods. So then any abstract methods like prepare and store would actually have to be written now as when you make a abstract class and inherit it to a child class. That's what happens. And again, you should read about that in the notes or watch the videos on the use of abstract classes. So we did that. We made a banana class, and we wrote a constructor for it, that it's in food group 0 and that it's sweet. We wrote that yes, you can eat it, how to prepare it, and how to store the banana. We also made a donut class in the same way, which food group it falls into, what flavor, how you eat, prepare, and store a donut. And then we incorporated that into our testing class. Just close a few of these at this point. Mr. Brooks, meeting, food, banana. And so we made a banana object and a donut object. And then what we did was we went, oops, I closed it too early, into the person class. And within the person class, we added, which is the first class we made in this unit, we made a method called have dinner, which uses a food object as the parameter. And what it says is, if the food has nourishment and the flavor is sweet, smell the food, prepare, eat, digest, and store the food. And if it doesn't have nourishment, do this. It was just a little fun method to incorporate the food object into the person class. And then we tested that by having our Mr. Walks object, which is a it's a Mr. Walks object, which is a computer science object, computer science teacher object, which is a teacher, which is a person. So this method passed along through all that inheritance. And it was able to do that and have a donut and have a banana. And there you can see that the method started getting executed and running in our outputs. Then, once we'd finished that, we then moved on to the concept of an interface. And again, definitely should read about that. What an interface is and how it's different than a class, how it's also abstract, but even more abstract. That's where we went, was with interfaces. You can certainly read through the notes, but what we did was we created first a sports interface. Notice it's not a class, it's an interface. And all methods in an interface are by nature abstract. So they have no method body, just like the abstract methods. And all they are is just these signature lines for what the method will be. So a set name, set opponent, and did I win method for sports. Then we also made a hockey interface. Even though they're not classes, they can also use inheritance. So hockey is a sport. So it inherited those method signatures. Plus we added 2 more for hockey. What does it look like to get a goal? What does it look like at the end of a period? We did the same thing again then for football. We made a football interface with 2 method signatures. How to score in football. It had 2 different parameters. And what does the end of a quarter look like in football? Okay. Finally, we made something called a permission form interface. Now this one wasn't a sport, so it was an interface on its own. It had 2 methods, 2 method signatures. One is just sign, and one is have you got it signed, which returns a Boolean. And one other thing you can do with interfaces is you can create constants as long as they're static. So one to represent signed and one to represent not signed. And we finished up our online class by then making a class called the Husky Athlete, which is a Husky. So a Husky Athlete extends Husky, which is a class we made before the school closure. But then we continued to adding to that signature of the class, how it implements these 3 interfaces. And interfaces can have multiple implementation. So you can implement more than one interface by separating them with a little comma each time. So permission form, hockey, and football. And again, in the notes or in the videos, it goes over this in more detail, how you can think of interfaces like a set of rules to follow. So the Husky Athlete follows the rules of hockey and football and the permission form. What that ended up doing was it created a ton of empty methods that we're going to fill in next time when we have time. Okay, that is going to wrap it up for today. And that's just a summary of what we did in class on Wednesday. You can get all this code off of our 40S page, off of the GitHub example, as it's already been uploaded with comments into that example. All right, you guys, take care.